Hello viewers and my dear students. Welcome to session 7 on one-dimensional problems analysis. This is a demo on one-dimensional bar analysis using log file as input, that is creating a macro code in mechanical APDL, that is Ansys. This I have already started in the last session, that is session 6. In this session 7, I'll continue whatever I've done in session 6. See here, as you know, at the end of session 6, I'd done the same problem what we had done earlier and the log file. Okay, if you see here, file, list, log file, if you do, you can see clearly what exactly we had done. All would have list structure. This is structural one. That means we have done structural analysis, link 180 and all that. This will copy. Okay, this I'll copy. Okay, full up till the displacement I'll copy. Okay, this Control C I'll copy and I'll paste it. I'll paste it here. Okay, I'll paste it in the word, let us say. Now what I'll do, once I paste it in the word or WordPad or whatever it is, notepad, you see here the same thing you would have got it. Okay, you'd see here. Now as you see here, this whatever log file we have created, I have created in a word file. Now you can clearly understand what exactly is the log file created. See here, these are all 00. That means we are doing structural analysis. Okay, this is a file. This is a programming. Okay, this is programming using log file. That means using this only you can do the analysis. You can directly do this also. This macro creation, this is called macro creation or creating log file creation. This itself you can practice and do. That means you do this and directly copy. I'll tell you how exactly to do that and all that. Now here structural, this is 1, the other things are all 0. See here we are not doing any other thing. You see here element 1, link 180. Okay, element is only 1, link 180, and real constant 1, 900. Real constant 2, that is real constant 1, 900 it is for steel. Real constant 2, 600 it is for aluminum. That is what I have just darkened it only for understanding purposes. Then material property data, these things I have not done. This has been created by Ansys. In the log file automatically it was there. I had just copied and pasted into this word. Okay, just to make you understand, I copied it. I'll recopy this and paste it in the Ansys to get the answer. Okay, now you see here element material property data, 1 is aluminum 2E5, material property data 2, that is aluminum 0.7 e to the power of 5. Then you see here key point 1 000, key point 2 600 00, key point 3 1100 00. Then I have just I have created that is lines, straight lines 1 to 2, 2 to 3 I have created. Okay, can you understand? Then once I have created key points and are joined by lines, okay, it says how it has done. This I have not done. Automatically it has been done. You just have to copy. You have to make use of this. That's all. Okay. Then how it has done is, you see here, for 1, I have gone for meshing. This meshing has started here. Can you see this meshing? This meshing for 1, you see here, I have selected the line 1, line 1, okay, and I have attributed the properties 1, real constant 1, material 1, and link is 180. Only one element has been used, that is 1 is link 180. Okay, this is the thing what I have done it for the first line. Okay, line 1, these are all the properties I have attached. That is real constant 1, material 1, and link 180. 1, link 180 it is. Okay. In the same way, for 2, you see here, real constant 2, material 2, and the material, that is element is 1, that is link 180 only. That means for both of them, it is 1, 1, 1, real constant 1, material 1, 1 link 180. This is real constant 2, material 2, 1 link 180 only. Because link 180 is the common element what is supporting our analysis. We have not changed the element. Okay. Okay. In that way, then you see the size controls and all that. That is, once I have done this, okay, and once I have done, the size controls are done. you see the size controls for both of them, I have made one division. That is aluminum also one, and sorry, steel also one, aluminum also one. That is, once I have done this, okay, only one, then I have meshed it. After meshing, that means up till here, after meshing, this is the code for meshing and all that. This is the macro codes and all that. It has generated. I have not done anything. Okay, that is after meshing. Actually, I had saved. If you remember, in the previous session, you see, I had saved. That save also it has come. Okay. Then you see here. Then after saving, I'll give the boundary condition. That means up till here it is a pre-processing. After this, it is solution phase. In the solution phase, for node number 1, I'll make all degrees of freedom 0. 0, 0, 0, all degrees of freedom 0. And the item that is for node number 3, I'll give the force in the x direction, you see here, fx 500. Okay, I've just darkened only for your purpose. It has already given. I've just darkened it only just to make you understand. Okay, 500, fx 500. Then after that, I just done solve. Okay, solve, that means that automatically after solve, it is finished. Okay, now it is post-processing. Post 1, you see, it is post-processing. And you could have continued. But I have just done for your just exam, that is for understanding purposes, up to U component I have gone. That means that is displacement at different nodes. That is U. Okay, different displacement at different nodes. U1 is 0, U2 and U3. You know the answers and all that. You should get that. Okay, what I'll do now is this. I'll just copy it. You see here. This, you see what I'll do. I'll just copy this. Okay, up till here, I'll Control C. Control C I'll do. Okay, I'll go to this. Okay, see here. Now I've done something. I just don't want all that. I'll just say file clear, start new. Okay, do not read file, nothing I want. Okay, just say okay. Remove everything. Now nothing is there. Okay, nothing is there. Now you see here, there is nothing here. Okay, it is nothing here. What I'll do, whatever I copied, you go to Ansys command prompt. This is Ansys command prompt. You go here, Control V you put. Okay, whatever I have copied, it will come here. Then press enter. I'm telling you again, press enter. Once you press enter, whatever I've done here, it's here. It is automatically getting executed. Line by line, it is getting executed. Just see, solution is done, close. Okay, now you see here, I've done only up to here, no? I've not gone for e-table and all that. You see here, solution is done also you got. And 1, you see here, 0.1667 into t 10 to the power of minus 2. This is 0.7619 10 to the power of minus 2. What we had got answers here, the same answers here, 0.16 into 10 to the power of minus 2, 0.73 into 10 to the power of minus 2. Same answers, we have got it here, 0.1667 into 10 to the power of minus 2, 0.73 here. Now it is 0.76 into 10 to the power of minus 2. Everything I got. That means, see here, the advantage here is, you see here, file close, let us say I'll do. Okay, now you see here, what I'll do, see, let us say you are doing the analysis. Now, you see here, right now, the displacements are, as you see here, under general process, you just now see nodal solution. Displacement, as you see here, it is 0.1667, 10 to the power of minus 2. It's all very small displacement because it is the force applied is only 500 newtons. Now, what I'll do now, you just see what I'll do. I'll just go here. I know where exactly is the force applied. Okay, key point 1 and key point that is 0, 0, 0. Here you see. Now I have done 500, no? 500 was the force applied. Now I'll take 50,000. Okay, 50,000 I'll take instead of 500 newtons. I'm making 50,000 newtons. You just do this. Now I have changed this. 500 is easily, it is changeable here. Even in the same way, you can make changes even here also, in the key points also. Okay, in the area of cross sections also, Here also real constant 1, real constant 2 also. In the key points also you can change the that is distances 0, 0, 0, 300, 0, 0, some 800, 0, 0, anything you can do. Okay, now I have changed it. Now as you know here, this is 50,000. Okay, now what I'll do, you see here, what I'll do, I'll take this, Control C, okay, Control C, I'll clear start new, fit, fit you do, okay, now fit you do. Now what I've done, only thing what I've done is, now nothing is there now. I have created a new one, but only thing is 500 I have changed it to 50,000. Now Control V I'll do. Okay, after doing Control V, I'll press enter now. Once I press enter, it will be executed for the new load. You see here, slowly, I'm not doing anything. My hands are here, automatically the load, everything it is got, solution is done, you got. Now as you see here, if you can clearly verify the solution is done, close, and up till here, whatever we have done, you see here, the 50,000 load, it is 0.166 into 10 to the power of minus 2 it was. Now 10 to the power of minus 2 it has gone. Now since everything is Newton meter millimeter square we have done, it has to be in millimeter only. This is millimeter, 0.16 is the millimeter, 0.76190 is the millimeter. Okay, that means so much was the displacement at node 2, node 3, and node 1 it is 0. Okay, in the same way, I have told you, you can make any number of changes here. That is the advantage of this macro file creation and all that. See here, let us say I'll go and I'll take this again. Let us say I'll make it I'll make it 1 lakh, let us say 1 lakh. Okay, 3, 1, 2, 3, 4, 5. Okay, 1 lakh. Let us say I'll do. Okay, I'll copy this. Up to this, Control C, okay, go to this, okay, you go to this and file, clear start new you do, now you create a new file, okay, now as you see here, okay, now what I'll do, I'll create here, I'll copy this in the command prompt and I'll press enter. You see here, same thing, all whatever is that, one dimensional problem, creating macro code, log file, Professor Gurudat, everything. I'm not doing anything, automatically looking at the log file, it is doing its job. Okay, solution is done, close. Now you see the amount of displacement, what has been done here. See here, now it is 0.33 at node 2, at node 3, it is considerably increased. It is 1.5238 1.5238 mm. In that way, even if you calculate the axial stresses and all that, even that will also be more. Okay, those things you know how exactly to do. That is element. You see here, even general process list results, reaction solution. If you do, you see here all items. You see here. In the 0.1 into e to the power of 6, that is 1 lakh. 1 lakh in the other direction, and whatever you have done is perfectly okay. Okay, this is 1 lakh newtons. I put it in the positive direction, no, in the node 3. Now at the node 1, that is at the support, it is 0.1 into 10 to the power of plus 6 or 1 10 to the power of 5. Both are same. Okay, now it is exactly correct. In that way, the changes and all that you can do it very easily using this macro operations or log file operations. That is another feature of Ansys APDL, which is very useful to you. This you are supposed to know from the understanding the subject point of view. Okay, friends, thank you for watching. Thank you.